Howdy AS Math, it's Mr. Knight, and we're going to look at the unit circle since it's pretty much one of the best foundations of trigonometry into our understanding of kind of how this stuff works. So what you're going to need is you're going to need to take some notes. We're going to kind of work with this little unit circle that I made first before we tackle this guy, because we want to make this guy really neat so you can use it on your homework, on quizzes, on tests, from here on out, okay? So before we tackle this, let's tackle this first. If you're unable to print this guy out, just do your best in drawing one. I know circles are hard, as you can tell, and do your best. That's all I can ask for. Try to make it as neat as possible. Maybe use something with a circular base to trace. The other thing you might need is that chart from yesterday's notes where we have the trig functions and then the associated angles and the values we get from evaluating those, okay? So let's talk about the unit circle. Let's talk about what it is. It's kind of like a unit vector. A unit vector has a length of 1. A unit circle has a radius of 1. And what we can do is, since I plot this circle on this coordinate plane, we're going to try and come up with as many coordinates as we can, at least useful coordinates, okay? So, for example, without even really thinking about it, I know what these 4 points are along this circle. If it has a radius of 1, well, this is going to be 1, 0. This one's going to be 0, 1, if it has a radius of 1, and so on and so forth. We are going the other way, so it's got to be -1, and this is 0, -1 right here. So now what I'm going to do is I'm going to actually create a terminal side as a radius. So basically what I'm going to do is I'm going to take my marker and I'm going to make some kind of radius coming out of this circle. And I want to talk about a little bit of terminology first, kind of using this little guy down here. So I said terminal side. The terminal side that I'm referring to, whenever I have like an angle between two sides, would be this side right here. We call this a terminal side because it's kind of like the ending side, right? You're measuring an angle from this first side, which we call the initial side. Measure an angle from the initial side to the terminal side, and that's how we get that angle. We're not going to write formal definitions, but I just kind of want you to be aware when I use this terminology right here, okay? So the initial side for this circle, and pretty much this entire unit circle, is always going to be the x-axis, okay? Maybe let's write that. Initial side on unit circle is always the x-axis. Okay, just as a note. So we have our terminal side, and we know how long that side is. It's got a radius of 1. So now what I'm going to do is I'm going to actually create a right triangle out of this. So I'm going to drop an altitude right here. And I'm going to make it very clear that that's a right triangle. And what we're after is this point xy right here. We want to know what that is, kind of extending our ideas of trigonometry and our functions that we've come up with so far. So I'm also going to generalize this. I'm going to call this side length A. I'm going to call this side length B. And really, A and B are corresponding to the x and y coordinates of P, right? In order to get this point right here, well, I got to go in the x direction A, and I got to go in the y direction B. So that's kind of nice to know that A comma B also refers to x comma y. We could take these ideas a little bit further. I'm going to have another sheet of notes because I want to make sure we have a nice, like, clear place to put some of these generalizations that we come up with. And so let's start with what we know with sine, cosine, and tangent, because that's really all we have with trig. If I do the sine of this angle right here, because now I have an angle that's measured from the initial side to the terminal side, I know my sine is going to be opposite over hypotenuse. Well, the opposite over hypotenuse is just b over 1. So sine theta is going to be equal to opposite over hypotenuse, and it's going to be equal to b over 1, which is just b. Okay, I can do the same thing with cosine theta. Cosine theta is my adjacent over hypotenuse. In this case, that is a over 1, which is just a. And it actually turns out, if we're thinking about this in terms of coordinates, right, we already declared that a and b are representing x and y. But we found a and b to be cosine theta and sine theta respectively. So that means that if I have x comma y on the unit circle, if I want to find what those points are, I just need the angle. I need cosine of that angle and then sine of that angle to get my x and y coordinates out of that. Just pretty sweet, actually. Kind of like a little cheat code, honestly, that all we need is that angle to kind of get a good idea of what's going on with this. Let's move on to tangent, because that's the other trig function that we know about. Tangent theta is equal to opposite over adjacent. And if I look at my opposite over adjacent is b over a, which once again, we have declared b and a to be sine and cosine. So this is sine theta over cosine theta, and that equals tangent theta. What I'm going to do is I'm actually going to box that, because this is a trig identity. Okay, it's like an axiom. It's a fact. It's kind of like Pythagorean's theorem: a squared plus b squared equals c squared. Sine theta over cosine theta equals tangent theta. I'm also going to box the xy coordinate that corresponds with the trig functions, because that might also be really, really helpful. Now, this guy's going to be more helpful for your quiz that you're going to do on this stuff. This guy will be helpful in your quiz, but it's going to be more helpful tomorrow, so we're going to come back to him. And speaking of Pythagorean's theorem, there's actually one more interesting identity we can get out of this, and that is using Pythagorean's theorem. If I use Pythagorean's theorem, a squared plus b squared equals 1 squared, so a squared plus b squared equals 1. I know what a and b are in terms of sine and cosine, so this one's actually called Pythagorean's identity, and it goes like this: b squared plus a squared equals 1 squared, right? And that is another trig identity. We're going to just call them trig identities for right now. We're not going to need to formalize them too much, but we are going to be using them as we go forward. And this opens the doors for things we can do in terms of rearranging trig equations and solving them outright. Okay? So these are our notes. Let's use them as we fill out our unit circle. Okay? Let's see what we got. So what I'm going to do right off the bat with this unit circle is I'm going to write at the very top, I'm going to write x comma y, and I'm going to say that that corresponds to cosine theta comma sine theta, just so we have it right off the bat. Okay. I'm also going to put in those known points that we got, because what I want us to do, and you can kind of see what I'm getting at, we're going to be having a bunch of different angles, and we're going to try and find the points at each of these points right here. We're going to find those coordinates. Okay. We're going to do it with trig. Okay. So now, what are these guys referring to? Well, these are actually referring to our known angles with those special right triangles, the 30 degrees, 60 degrees, and 90 degrees. And what I'm going to do is I'm actually going to start labeling those. I'm going to do it in different color, just to kind of drive this point home a little bit more. And you're going to see some symmetry and some patterns that you might not be able to recognize right away with this unit circle, which will be more apparent with the color differentiation. And then I can't forget 0 degrees. That still matters. I can't forget 90 degrees. That still matters too. All right. So if we want the x and y coordinates of that, remember, we said that the x and y coordinates are just the cosine theta and the sine theta of this given angle. But we know what those values are because we filled them out yesterday using our triangles, right? We know that 30 degrees, the cosine of 30 degrees Well, that's going to be square root of 3 over 2. And likewise, I know sine of 30 degrees is just 1/2 based off my chart. And what I can do is I can fill out the rest of these points, these coordinates, knowing my chart. And that's all I'm going to do. I'm going to use my chart to fill out the rest. And that's kind of a nice little cheat sheet. Okay, pretty sweet. I'm going to take this a little bit further. I'm actually going to color code these completely. Forgot to do that, so let's not forget. All right, sweet. That'll become apparent shortly. Well, because we're using a circle, we are not confined to 0 to 90 degrees, right? That's just one quadrant. Let's call this quadrant 1 because, well, that is what it is called. Call this quadrant 2, right? Quadrant 2, quadrant 3, and quadrant 4. All right. But let's start getting the other angle measurements because we can obviously get those. 90 degrees, this is 180 degrees, this is 270 degrees, and we actually get back to 360 degrees. Okay. Let's go ahead, let's actually count by 30 degrees just to start. So 30, 60, 90. This guy is going to be 120. I'm going to color it green. You're going to see why in a little bit. That is 120, and then after that, if I count by 30 again, I get to 150. Count by 30, I get 180. Count by 30, I get 210. 210 is going to be blue. 30 is 240. That's green. And then we keep going. The next one is going to be, if I count by 30, 270. This is 300. And then this will be 330 right here. Okay, and let's not forget the 45 degrees. Let's count by 45. So 45, 90, 135. What color I use for that? I use this guy. 45 plus 180 is 225. Plus 45 is 270. Plus 45 is 315 degrees. So now, why did I color code those the way I did? Well, what I'm going to do is I'm actually going to show you the reference angles of these guys. What the heck's a reference angle, Mr. Knight? Well, let's talk about that, because they're pretty substantial to extending our ideas of trigonometry past just the confines of a triangle. Okay, I mean, they are the study of triangles, but we don't have to just stop there. Okay, these are reference angles. We're going to get a nice little rough definition of what a reference angle is. Finally put all these colors away, man. It's just a minefield out here of markers, man. My hands are getting all dirty out here. It's crazy. Okay, going back to my note sheet real quick, I'm going to actually write a definition of what a reference angle is. Okay, so for a reference angle, and I'm going to be using the terminal side and initial side as reference. A reference angle is basically an angle measured from the terminal side to the initial side. Okay. Okay. So it's an angle measured from the terminal side to initial side, and it is always acute. I'm going to say it's always an acute angle. Not just that, it's cute. Okay? So, for example, might want to draw this too. If I have an angle that is right here, right? Well, I could go ahead and I could measure that, right? I could measure that. I'm going to call that alpha for right now. But remember, I want to measure this terminal side from the initial side. I declared that the initial side is always the x-axis. It's always this guy right here. And my terminal side is going to be, well, this guy right here. This guy poking out. So actually the angle that I'm measuring is this right here. It's also acute. This guy is clearly obtuse. It's over 90 degrees, right? So how do I actually get those reference angles? Well, there's actually a nice little way of doing it that we're going to fill out right now. So on our unit circle chart, let's start making some reference angles. So below the quadrants, where I wrote quadrants, I'm going to put ref, just like that for reference angle. And this guy, I'm just going to say for quadrant 1, well, alpha is going to equal theta. Okay, they are the same angle. There is really, this one's the easiest one, right? Well, if we think about quadrant 2, and this is kind of what we had in this diagram right here, if I want this angle, I'm going to have to do 180 degrees minus alpha right here. Right? That is what's going to give me my theta right here. So I'm going to write that below or around quadrant 2. I'll write it above. Reference, this is theta is equal to 180 minus alpha. For quadrant 3, its reference angle. Okay, if I think about like 210 degrees. Well, if I want that reference angle, that means I just want this little angle right here. Well, that's going to be 180 degrees, or it's going to be whatever this angle is minus 180 degrees, right? So it's whatever your starting angle is minus 180 degrees, okay? So it would actually be the other way around. It's actually alpha minus 180 degrees equals your reference angle. Okay? And then finally quadrant 4. If I want 330 degrees and I want its reference angle, then that is going to be, well, again, it's the acute angle between the initial side, the x-axis, and the terminal side in blue. So to get that guy, well, if I'm going all the way around, that's going to be basically 360 degrees minus whatever this this angle is right here, right? So the way I can write that is like this. Theta is going to equal, it's going to be 360 degrees, right, minus whatever this guy was, that alpha. Okay, and that's actually how we can get a reference angle. Let's test it out. Well, if this is my blue reference angle, it should have, should be technically the reference angle of it should be 30 degrees. And so if I go all the way around to 330 degrees, I'm going to do 360 minus 330. I'm going to get back to my reference angle of 30 degrees. Why are reference angles important? Well, because they actually can tell us the rest of the points without thinking about it too much. For example, since 120 degrees and 60 degrees are reference angles of each other, that means 120 degrees is going to have the same values for its x and y coordinates. There is a subtle difference, though. And if you're looking at this, we are in quadrant 2, right? So the x value is negative, the y value is positive. So that is the difference right there. If we continue on, like if I look at 240 degrees, well, the values are the same. That is still 1/2 comma square root of 3 over 2. But we're in quadrant 3, so the x and the y are both negative. And we can continue this idea for the last one. This is going to be positive 1/2 comma negative square root of 3 over 2 for 300 degrees, since it corresponds to the 60 degree reference angle. So the last thing we might want to include on our chart is just the signage. Right, so I'm going to put positive, positive right here. I'm going to put negative, positive, and so on and so forth. This is negative, negative, and this is going to be positive, negative. So before we wrap up, just a couple things to keep in mind. You're going to have a mini quiz on this stuff. So a lot of it is going to be talking about like what is this point got to be, or what's this angle got to be to get this. You know, you're basically going back and forth with maybe the points and the angles and vice versa. I might also ask you about a reference angle, but I might not give you a nice reference angle. I might be like, hey, if I have 285 degrees Well, what would the reference angle be? How would you figure that out? Well, you do it just by doing this. If you have 285 degrees, okay, 285 degrees, you're going to be somewhere in quadrant 4, right? So 285, you're just going to do 360 minus 285, and you're going to get 360 minus 285, which you get 75 degrees. So that would be the reference angle to the 285 degree angle, okay? So good luck on your quiz. I think you guys are going to do just fine.